A long time ago in a consultancy far away, a group of us had a problem. We'd become addicted to test-driven development and found it wonderful. But we'd learned that lesson through stepping into a series of pitfalls over the years. Now we were past that and we were seeing the real value. But now we were in a position where we were teaching it to other people. And teaching it was hard because people were falling into the same pitfalls that we had. They focused too much on the importance of unit testing and got tightly coupled tests and systems as a result. They focused too much on the illusion that is coverage and got themselves into a mess that way too. I think you can best paraphrase this all into test first is hard. Let's just write lots of unit tests afterwards instead. And that's what most people did. So a few of us tried to think of a better way to teach test-driven development to help people overcome those early stage stumbling blocks and get to the real high value stuff sooner. Dan North and Chris Matz kind of led the charge on this. They were the prime movers and they invented behaviour-driven development to help teach the real value of test-driven development. So, how can you use behaviour-driven development to help you write better software faster? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't already, please hit subscribe and like if you think that's appropriate at the end of the video. In this episode, I want to discuss a collection of tips that will help you improve your approach to BDD. The idea for BDD, as I said, came mostly from Dan North and Chris Matz, and they were focusing on trying to get the words right to help us teach TDD better. Test is the wrong word. Specification is a better word for what we're trying to achieve. Test case is wrong. Scenario is a better description of what it is that we're trying to capture. And then they came up with the given, when, then pattern and tricks like starting each specification with the word should to put us into the right mental state to capture the behavioural intent of the specification that we're trying to write. BDD was invented to focus on these higher value aspects of test-driven development and was aimed at reducing the coupling between the specifications that we wrote and the system under test to give us greater freedom to change the system under test and retain the value in the tests that we captured. It was extremely successful at this. I spoke about some of these attributes in an earlier video on BDD. If you're interested in that or those, there are a couple that are on this topic, check them out. I'll put a link up there. BDD does not require specific technology. It's not only about acceptance testing. It's an approach to automated testing that you can apply at all levels of detail, from the finest grain of test-driven development style unit tests to broad system-wide functional tests. It's aimed at a focus on design rather than on testing. And Chris in particular was an analyst and a product owner and was kind of bringing a much higher level of thinking into the discussion. It's not just about the nuts and bolts of automated testing. BDD is widely misunderstood. A good place to start is to think in terms of the language in which we would like to express our specifications. And as I said in an earlier video, this is really importantly based on the ubiquitous language that we try to establish around our problem domain. We want to express these things in the language of our problem domain. But it would be foolish to try and take on the job of trying to write natural language parsing at the same time. We don't want it to be a real human language. So what we're looking to establish is some kind of computable, simplified grammar that will express concepts in a way that's understandable to somebody who is not necessarily a technologist but understands the problem domain. And this is the realm of domain-specific languages. There are two broad categories of domain-specific languages that are worth thinking about. There are external DSLs, These are languages that have their own parsers. They have their own separate tools that will capture and interpret the language and transform that into something executable. Here are a few examples. The first is an example in the Gherkin language, which is the one that's used by Cucumber and SpecFlow. The next is one of the really early examples of this. It's a very crude DSL in some ways, but Fitness was effectively a simplified DSL. It was focused primarily at capturing the data that we wanted to inject into our test cases and didn't go much beyond that. But you could do some really interesting things when you started applying this kind of DSL idea, even with the tools of Fitness. And then the first genuine BDD toolkit was JBehave. This was Dan North's open source project at the time when he was working with Chris on the development of BDD as a concept. My own preference, though, is for internal DSLs. And internal DSLs are basically using your existing programming language to host a computable grammar that acts as your DSL. There are several advantages to this from my perspective. One, I'm using the tools and techniques that I'm familiar with and have freedom to play with this in as many different ways as I want. I can grow the language in any direction that I want because I have a genuine Turing complete programming language at my fingertips. I also get the leverage of all the tools that surround that. I get code completion facilities and all of those kinds of things. And finally, the speed of execution is quite high. It just reduces complexity. I have no real argument against the external DSLs, but the internal DSLs, I think, work slightly better for me. Here's a simple example. This is based on an open source toolkit called EasyBee, which is written in Groovy. And here is one of my homebrewed versions using in Python and another written in Java. You can see that these are still fairly expressive pieces of code. But in these cases, I think one of the significant differences in terms of the kind of DSL that you end up with in an internal DSL rather than an external is that we worry less about the natural language part of the problem, and we're just going to create an easily computable grammar within our language set. Now, it turns out that human beings are fairly sophisticated parsers of language, and so even in these cases, these relatively technical DSLs, what I have found in practice is that human beings can, even non-technical human beings, can very, very easily parse these and understand what they mean because all of the words are words from the problem domain. I showed you this simple example before, and I'm not going to go into it again in terms of separating out what's important, but capturing our specifications in the language of the problem domain is really, to my mind, perhaps the most important aspect of BDD. This is really fundamentally about separation of concerns, and the separation of concerns in the specific context of separating out the concerns of what we want our software to do from how it's going to achieve that. We want our test cases, our specifications, to only express behavioral intent in terms of what we want our software to do, and never to touch on how it's going to achieve that as far as we're able to do that. I have another video that gave some examples on that, which I'll put a link to up here. Good software development is nearly all about abstraction and separation of concerns. Design should go beyond a naive sequence of steps. It's not just do this, then do that, then do the other. We're trying to be a little bit smarter about that, to synthesize seams within our code that separate one part from another and allow us to make progress in one area of the code more independently than in another. Good design allows us to navigate the information space of the problem and the solution. It gives us a way of finding our way around. Naming is critical to this and is a key important technique in achieving good abstraction. So here are a few tips to think about naming. First, be explicit. Pick clear names and avoid any abbreviations that are at all specific to your problem. Some generalized abbreviations like RAM or something like that are acceptable. But if you have abbreviations that are only known in the context of your business, don't use them. Spell them out so that an intelligent reader will be able to understand what's going on in the context of your code, tests, specifications, wherever. Keep classes, functions, and methods small so we can name them for what they really do, and try to avoid comments. There's good advice on comments that says, don't say in comments what is going on in the code. This is equally true of tests and specifications, by the way. But I think that's good advice. The next part of that advice is usually say in comments why something is happening rather than what is happening. I think that's fair enough as a guideline. My own preference is to not care, to try and write code that doesn't need to be commented. If you can achieve that, it's going to be simple enough that people don't really care about the whys or the whats. It's clear in the code. Make sentences, create sentences in your code and particularly in your specifications that make sense. Establish a ubiquitous language for the problem domain and use that wherever you're writing code or specifications. Here are a few examples, and I've picked the first of my examples is a real one from a project that I once worked on. Here's the name of a key class, a key service in that the application. Any idea what this is doing? Me neither. This is a terrible name. It's kind of a cool name. It sounds cool, but it tells you nothing at all about what's going on. This would be an acceptable name if I was writing some software to do with astronomy and I wanted to capture the idea of galaxies. But in this case, I wasn't. I was working on a trading system. What does a galaxy have to do with the trading system? I think this is a poor naming, and I think it doesn't really give you any insight into the code. I'm still not entirely clear on what really the key responsibilities of that service were. And I think that was because the responsibilities weren't very clear. Next, my favourite Harry Potter character. Too long, too vague, too clear. It's not telling me anything about what's going on in the code. I-A-X. What? I don't know what's going on. It's too abstract. It's too divorced. There are tiny contexts where maybe you could use an I as an iterator because that's become a bit of a convention. Maybe you could use X to mean an X coordinate or something like that. There are narrow contexts where maybe these sorts of things are meaningful. But in general, single letter variable names are a terrible idea wherever you use them. Data, text, too general, too generic. Well, what does that mean? It's not telling me anything. Again, in very, very, very narrow contexts, I could imagine maybe being able to use those sorts of names, but in general, they're terrible names. Anything that ends in the word manager probably means you don't really know what it does, including real managers very often. The customer list with all customers included without filter. I once worked with somebody that used to write method names that looked like that. Too much detail, not enough information hiding. I want it to be clear, but I don't need to read a book. Set object value. Oh, really? It's what does that mean? It doesn't really tell me what the value's for or what the object is for. Really, really quite unpleasant. Customer. Now, maybe that's probably a good name. That in many contexts, the idea of a customer probably makes some sense. All customers, the list of all customers, the collection of all customers. Again, very sensible, very useful. It's going to inform me what's going on in the code. Line item. Yeah, in many of the domains that I've worked, so I've probably got a concept of things like a line item. And certainly for me, ideas in working in trading systems, ideas like order book were often central to the work that we were doing. These are all good names and give you a loaded mental model of what's going on. We started off talking about BDD and specifications, and I've ended up diving into the kinds of names that we use in code. I'm using this really to illustrate the importance of trying to capture ideas from the problem domain, establishing this ubiquitous language and using it ubiquitously. Use it in the specifications, use these sorts of concepts in the specifications, and that will remind you to tend to use them in the design of your code as well. Next, onto the scope of these tests. Good code has a clean separation of concerns. One class, one thing, one method, one thing is a really quite fantastic rule to follow. Good tests are the same. Test behaviors, not implementations, and test single behaviors. Test one behavior at a time in each test. Don't worry about trying to save time and effort by bundling up lots of evaluations into tests. The complexity will be a bigger cost than the speed of execution. It's relatively cheap to invest in some extra server capacity to run more of your tests in parallel than it is to try and decompose a tangled mess of complicated test cases. Use the should naming convention. Think of start all test names with the word should, and that should help you to come up with a sensible description of the intended behavior of your system. Assert one thing per test. Going back to what I said, there's a lovely quote from a friend of mine, John Jagger, who says the cyclomatic complexity of a test should be 1. We want the tests to be almost perfectly simple, very, very clear. On the whole, tests should look like this, not like this. We want our test to be simple, asserting one thing at a time and then getting out of the way. We don't want to have massively complicated setup, lots of complicated evaluations, and complicated teardown at the end. Moving on, naming tests. If naming is important, then naming tests is important. It aids the communication. If I can read the name of a test and it tells me what it's doing, that gives me a big step up in understanding where I am and what comes next. It limits the scope of the test. If I've got a good test name, it's going to keep me focused when I'm working on that to achieve that goal that the specification outlines. Begin with the words should, avoid test this method kind of names. Implement should do this thing tests instead. This is all part of BDD and kind of really important. It's simple, but it's important stuff to get right to help us down the track to separating the what from the how. In their fantastic book, Growing Object-Oriented Software Guided by Tests, Steve Freeman and Nat Price gave this piece of advice. Take the thing that you are testing and use it as the subject of a meaningful sentence that describes what it should do. Here are a few simple examples. This approach is sometimes referred to as test docs. So, a list should store items in the order that they were added. So we're going to have a test called list test. And we're going to have a test case, a specification, that says should store items in the order that they were added. A list should hold multiple references to the same item. We're going to have a list test, and so taking the name of the test, list test, and taking test off, so a list should hold multiple references to the same item. And finally, a list should throw an exception when removing an item it doesn't hold. List test, list. A list should throw an exception when removing an item it doesn't hold. This kind of readable code is a big help in moving us forward and keeping the use of the ubiquitous language pervasive throughout the development process. Let's take a quick look at some examples in the wild. Here's a test that I downloaded from an open source project. And here are the import statements for this test case. At this stage, I don't know about you, but I'm already feeling nervous. If I've got that many imports, this test is going to be somewhat complex, is my guess. And our guess is right. Here's the test case. Here's a single test case, a single specification. Let's take a look and see how it fares given our advice on how to organise things. The name of this test case is Upstream Project Security. So we're all clear now. We know what this is doing, right? Yeah, me neither. That's not really being very helpful. Maybe if we look at the name of the test case as a whole, this scenario will become clearer. The test case is called a reverse build trigger test. So if we try out Steve and Nat's advice and try and form a sentence out of this, how do we fare? A reverse build trigger should upstream project security. Great, we all know what's going on now. Oh no, we don't. This is clearly not a very well named test. So that's not a great starting point. Now let's take a broader look at the test. We've got some single character variable names. R is obviously an important thing. It's reused in several places, but don't really know what it is. And just looking at this test, there's no way of telling because it's defined outside the scope of this test. So I went through this code and tried to figure out a little bit more of what's going on. The first part here, I think, is mostly set up. So this is given. And then there's a little bit of when, the actual actions, that's kind of a reasonable amount of when. And then there's a then. Then there's the result, the assertion that we're trying to expect. And then there's some more. So there's some more given, some more when, and some more then, and then some more, and some more, and some more. Okay, so if I get a failure at the end towards the end of this, how do I know what went wrong? Is this failure close to where it fails, or was this failure caused by something else that happened earlier? It's going to take me a while to figure that out. If you just base the analysis of this case on the number of given, when, then combinations there are in this scenario, there's a minimum of 5 tests here. And that's all kind of compressed together into one test. Clearly, obviously, as plain as the nose on your face, this specification was not written before the code that it's evaluating. You'd have to be some kind of crazy person to write something like this before you had the code to test. So clearly they weren't practicing test-driven development or behavior-driven development in doing this. They were doing something else. They were doing unit testing. Let me be clear. Unit testing is better than doing no testing at all, but it's not in the same game. It's not in the same ballpark as test first, test-driven development, and BDD, which is a step on from test first, test-driven development. Fundamentally, though, BDD is a fairly simple idea, an organising principle around which we can structure our development by starting off creating our specifications and working to fulfill those specifications. It's a great set of guide rails to steer us towards a more successful outcome. It has a big impact on the quality of our work, and it allows us more profoundly than any other approach that I know to separate what the system should do from how it does that. And that's an important, valuable separation to achieve. BDD encourages to use the ubiquitous language and to start thinking more deeply in terms of the problem domain. And in my experience, that's nearly always a good outcome. It allows us to make effective, useful, incremental progress towards our goals. BDD has little to do with tools, even successful tools like Cucumber. BDD is much more about the kinds of ideas that I've been discussing today, rather than the tools and the technicalities of me fulfilling those ideas. My own preference, as I've already stated, is to be fairly light on tools. On the whole, I'll just use the unit testing framework that comes with the language that I'm working in. I create my internal DSLs hosted in my programming language of choice for that project and work that way. But the ideas are much more important than the technology. Concentrate on what you want the system to do, not how it does it, and be thoughtful about the names that you use and the language that you use to describe these scenarios. Thank you very much for watching.